there it is.
What are you searching high and low there?
So for the cable to connect the hard drive.
Okay. So any luck? You got luck, right?
Yep, pretty much.
Got lucky or not?
So yeah, just 1 second.
Yeah.
Okay, hard drive connected.
Okay, so wanted to take few questions from repository as Vasudev did ask for a revisit of the portion with the big questions. So let us take it to the magnitude what is required of IIT. We are not to rush through any topic as we are aware of these being of import to us when it comes to the examination, even Olympiads. So we'll be taking few questions before we move on to the next topic, which is in offing, and the next topic being ray optics, wave optics. But as per the request, let me take a few questions. So this class, this lecture is primarily designed to reinforce whatever we have studied vis-a-vis EMI and alternating current. I'll be taking few questions to begin with. Write down a capacitor with capacitance C. A capacitor with capacitance C, a coil, and a coil with active resistance R, inductance L, and a coil with active resistance R, inductance L, are connected in parallel to source of sinusoidal voltage of frequency omega. The first ask will go in turns. So I'll limit to first ask. The first ask of the question is, find the phase difference between the current fed to the circuit, and the source voltage. The current fed to the circuit and the source voltage. So how we'll go about it? Well, how many components are there? There are two components as per the question. The author have accorded you two components.
So before we proceed with this question, can I ask something?
Sure, please do.
So basically, whenever we study an LCR circuit, we study the components connected in series. I have a few confusions about basically when the components are connected in parallel. Could you just like briefly take up the topic once before we continue with this?
Sure, without doubt, we'll be taking it because series being taken in general, parallel I don't think they get elusive about. So we'll be taking parallel combination as well. Rest assured.
Yes.
It's part of the course why we are going for question deliberation. Video?
Yes.
Okay. So in this question, how many components? In fact, the questions which I have allocated, you'll get a parallel combination here. You're not going to get series combination. We are referring to there being two components, right, Vasudev? One is the capacitor and the other is a coil.
Yes, sir.
One is capacitor and the other is a coil. The author has given you two components over here, capacitor and coil. That coil has got R and inductance to it. That coil has got R and inductance to it merit. By the way, to the serendipitous discovery, Vasudev, what you asked is what you are getting served with this question, and that being parallel combination. So we are taking parallel combination in toto. There will not be even a sliver of doubt. Without of this being taken would have been many litany of demand, but after of this, post this question will not be even a sliver of doubt on parallel combination. I assure you on this. What is being given to you is there is a capacitor, and that capacitor is in parallel with a coil which comprises of R and inductance, right?
Yes, sir.
So just to check what basically the author is into ask, the author is asking about there being a capacitor. So there's a capacitor I take. And then there being a resistor and inductor. R here, L here, C here. Why do we have doubts related to parallel combination? The answer being, where lie the answer, I would say, is we not relating it mathematically. We'll be relating it mathematically, and when I say mathematically, I mean complex representation, complex number representation. How do we go about it? Let me ask you, in this combination, if it's asked, as I'm taking in turns, if it's asked, find impedance, find Z for the circuit shown. How will you go about finding Z for the circuit shown? It is in parallel combination, right?
Yes.
So what are we to write? We are to write 1 by Z.
That applies, yeah. 1 by
Yes,
Z
dear?
effective is equal to 1 by Z1 plus 1 by Z2.
Yes. Is equal to 1 by Z1. And what will be 1 by Z1 is important. As Z1, I'm referring to capacitor. What will be 1 by Z1? 1 by Z1 will be 1 by minus of J XC. Now, this is important to understand. XC is follow-on conclusion, 1 by omega C, we are aware of it. Why do we have over here that minus J sign? That comes from complex number, you must be aware of. If you are rotating it anti-clockwise, you'll multiply it with J. If you are rotating it anti-clockwise, you will multiply it with minus of J. It comes from the complex number Euler methodology. E raised to the power J pi by 2 means rotated anti-clockwise. Minus of J pi by 2 rotated clockwise. So if one I am to take clockwise, the other should be anti-clockwise. For capacitor over here, it is in the sense minus J. Then for the other component, what I should write is an obvious 1 R plus J XL. Are you in concurrence? Do you concur to this, Vasudev?
So what is J again?
J is e raised to the power J pi by 2, Vasudev.
So you're saying J is equal to E raised to power J pi by 2.
Yes, when we are to multiply e raised to the power I theta, I think you can recollect. I told you that we write it in the terms of imaginary of this part, and we have a knack which should not be carried as it inflicts confusion to drop imaginary, write it in solo, e raised to the power I theta, the representation that we have for current or voltage, correct? Sinusoidal representation, right? Yeah.
Yes, sir.
If I multiply this with this factor, which is nothing but J to me, then what I'm doing to this, I'm rotating it anti-clockwise by pi by 2, correct? Yeah.
So 1 second, when the thing that you are hovering your mark over right now, is it e to the I pi by 2?
Yeah, it will be I pi by 2.
Yes, that just looked very convincingly
I
like a
or
JS.
J, whatever you mark, I pi by 2.
Yes, sir. Okay.
Okay. So multiplication will make it rotate
Pi pi by 2 and division will make
anti-clockwise by
it
pi 2.
rotate anti-clockwise by pi by
Yeah.
2. Yes, I get it.
That's the principle I am to apply over here. Am I clear with this one then?
So just 1 second.
Yeah.
So if
One is
just,
down, let us say capacitor is up, then inductor should be down, right? Yeah, pure capacitance, pure inductance. Pure capacitance up, then pure inductance will be down.